So some of you are asking questions about how you can directly use a table of values. So those are all the things from your exam. I'll just clear that one out. So what I'm going to do is enter in that expression from before. So we had x squared minus 4 over x minus 2. Is that right? Is that the expression? Yeah, what mistake did I make? Yeah, let's make sure we do that right. So x minus 2. And the question that some of you are asking is about, like, how do you set the table? So I'll show you real quick. If you go to table set, we have these options. This number right here, the table start, is the number that your table is going to start at. Imagine that. And this delta table is the change in the table. So that's where if you wanted to, what you could do, because we're trying to find the limit as x approaches 2, we could start this instead at, let's say, 1.8, and we can make the change in the table 0.1. And if we then go to the table, it's going to give us those values for y1, and we can kind of see, it's 3.7, 3.8, 3.9. We have an error at 2 because it's undefined, and then 4.1, 4.2, 4.3. But what I've said today is that's not what I want you to do to calculate limits. I want you to get closer and closer and closer. So I'll show you very quickly how to do that. We go to table set. I'm going to actually change the independent. This is the independent variable to ask. And what that means is it's going to ask me about every value that I want to put in. So if I now go to the table, I want to get closer and closer and closer to x equals 2. So I'm going to do 1.9 here. So we'll start on the left side. Now I'm going to do 1.99. 1.999. Oops, that's not it. 1.999. And so on. Look at that. Now let's go on the other side. 2.001. 2.01 and 2.1. And so in doing that, we can now see a pretty clear table of what's happening there. It's not approaching 3.9. It's not approaching 3.999. It's approaching 4. And that's how you can do this directly on the table.